So the best way to understand limiting reactants is to use the analogy of s'more making. And so, as we noted in class, in order to make a s'more, you need 2 rectangles of chocolate, 1 marshmallow, and 2 graham crackers. So let's say, for example, I go to the store and I end up with, I don't know, I'm just going to make up numbers, I end up with 4 pieces of chocolate. Okay. I end up with 20 marshmallows. And I end up with 6 graham crackers. All right, with 4 pieces of chocolate, since I need 2 pieces of chocolate for each s'more, I know I can make only 2 s'mores. With 20 marshmallows, I can make 20 s'mores. And then with 6 graham crackers, since you need 2 graham crackers for each s'more, I can make 3 s'mores. And so the whole point of this, why I brought up this analogy, is even though I could make 20 s'mores with the number of marshmallows I have, or I could make 3 s'mores with the number of graham crackers I have, since my chocolate limits the amount of s'mores I can make, I can only make 2 s'mores. So this concept is what we're going to be using in these two examples. Chocolate is my limiting reactant. It's what I began with, and then the s'mores what I end up with. And I can only make 2 s'mores because after that point I run out of chocolate. Alright, so let's look at this example really quickly. It says if I have 2.5 moles of copper, which is this reactant, and 5.5 moles of silver nitrate, which is this reactant, and they react, how many moles of silver will be produced? And then what is the limiting reactant? So what you should notice is that you have 2 given. So you have 2.5 moles of copper, so I'm going to write that right here. And then you have 5.5 moles of silver nitrate, so I'm going to write that below. So unlike previous problems, you're going to have to figure out how much silver, how many moles of silver each one of these is going to produce. Just like here, when I had 2 different amounts of reactants and I figured out how many s'mores that would make, I'm going to take the amount of reactant I start with and for each of them figure out how many moles of silver that will produce. And so the only thing I need to do here, because I'm already in moles, I'm going to go from moles of copper, I'm going to get into moles of silver. So I'm going to put moles of copper on bottom and moles of silver up top. Now the one thing I need to do before I can work with this reaction, I actually need to balance it. So I'm going to put a 2 here and a 2 here. And now I am balanced. And so what I'm going to do now is I'm going to use this mole to mole ratio. I'm going to use the coefficients. So I've got 2 moles of silver for every 1 mole of copper. And so 2.5 moles of copper is going to produce 5.0 moles of silver. At this point before, we just stopped. But the issue is, how do I know whether it's going to be 5 moles of silver, or what if this one produces less? That's how much silver is actually going to be produced. Just like here, even though this could have made 20 s'mores, it only could make 2 in the end because chocolate limited how much product I could make. So let's figure out here how many moles of silver will be produced from the silver nitrate. So I'm going to put moles of silver nitrate on bottom. And I'm going to put moles of silver up top. And then I'm going to use my mole to mole ratio. So here the coefficient for silver is 2 again, and for AgNO3 it's actually 2 as well. And so the 5.5 moles of AgNO3 is actually going to produce 5.5 moles of silver. And so if you look at this, there are 2 questions you're going to have to answer. The first question is, how many moles of silver will be produced? Just like here, even though I had 2 s'mores, 20 s'mores, and 3 s'mores, it only produced 2 s'mores. Here, because this is 5.0 moles versus 5.5 moles, only 5.0 moles of silver are going to be produced, because after that point, I run out of copper, because that's all the moles of silver the copper can produce. And so to answer the question, what is the limiting reactant? Well, the limiting reactant is copper, because it limits how much product I can make. Just like here, chocolate was a limiting reactant because it limited how many s'mores I could make. Alright, so this one was pretty simple, simply because I'm just going from moles to moles. What if instead I give you a problem where you're going from mass in grams into a new mass? Well, it's going to be just like the problems we worked on before, except now it's going to be a little bit of a longer process. So here my given is 80.0 grams of copper, and then I also have 25.0 grams of sulfur. And so for each of these, I'm trying to figure out how many grams of copper 1 sulfide are going to be formed. And so the problem is very similar to up here, except I now have to go from grams of copper into moles of copper, into moles of copper sulfide, into grams of copper sulfide, just like what we were doing in the previous section. So here I'm going to go from grams of copper. I'm going to first put grams of copper on bottom, moles of copper up top. I'm going to keep going before I plug in my values. So I have moles of copper here, and then moles of copper 1 sulfide here. And then I'm finally going to get into grams, so grams of copper sulfide here, and then moles on bottom. Okay, so this part isn't the new part. This isn't new, and what we're going to do below is not new. So I'm going to plug in my value. So for grams to moles, I need to plug in the molar mass of copper, which is 63.55. And 1 mole is going to be on top. Then here, my mole to mole ratio, I need to use my balanced reaction. Well, this isn't balanced yet, so I've got to put a 2 here, and then I'm balanced. So this is going to be 1 mole, because there's a 1 coefficient, over 2 moles of copper. And then I've got to, for grams to moles here, I've got to find the molar mass of copper 1 sulfide. Alright, so it's going to be copper, which is 63.55, times 2, plus sulfur's molar mass, which is 32.07, so I end up getting 159.17 over 1 mole. And so when I calculate this, what I get is 100, I want 3 sig figs, so I'm going to put 100 grams of copper sulfide. Okay? The issue is, while you would love to box that answer off and be done, I don't know if maybe sulfur doesn't produce as much copper 1 sulfide as the copper did. So we've got to see, because we've got to compare and contrast. So I'm going to put grams of sulfur on bottom, moles of sulfur up top. The nice part is you only have, so I'm going to put moles of copper 1 sulfide. I already know the molar mass of copper 1 sulfide, so I should be fine there. So copper, and then moles of copper 1 sulfide on bottom, and then grams of copper sulfide up top. And now I've got to plug in my values. Well, the molar mass of sulfur is 32.07. So plug that there, and that's a 1. Here, it's going to be 1 to 1 based on the coefficients. And then copper 2 sulfide, the good news is I actually already calculated it. It's 159.17 over 1. And so when I plug this in, what I get is 124 grams of copper sulfide. So while this problem requires more work, it's the exact same concept as what we did in this example problem, because at this point I know that what was produced as far as copper 1 sulfide is concerned, I know that I produced only 100 grams of copper 1 sulfide, because after that was produced I ran out of copper. So there's no way to make 124 grams of copper sulfide because I don't have enough copper to do that, and therefore copper is the limiting reactant in this problem. So the two answers I would ask for, how many grams of copper sulfide would be produced, and you would say 100. I would box that off to distinguish between 124 and 100. And then what is the limiting reactant? Copper is the limiting reactant. And that's it.